Utilities are turning to microgrids, small, local energy systems that can provide backup during outages, integrate renewable energy, or even allow them to operate off the grid. To learn more, I spoke with Laurel Schaich, who's worked on some of the most innovative energy projects in the water sector. Check it out.
A water utility's job is to provide drinking water or to provide wastewater treatment, and that's critical infrastructure. We wouldn't want a power outage to take down the drinking water for an entire city. We don't want our clients to have to issue boil orders, for example, because they lost power to their whole plant. So the microgrid can help build up different power sources to operate in different scenarios. So there might be a kind of your day-to-day scenario where you're operating typically like on the grid, but then you're bringing in some additional renewable energy sources. And then there's the emergency scenario where we decide that this pump is critical, this process is critical, and kind of allocate the power for those critical processes in a certain way to keep those operational and keep them moving to provide water and wastewater services for the public.
And I'm sure that folks working in water know this, but for those who may not, water utilities use a lot of energy, right? Whether it's drinking water treatment, wastewater treatment, very energy intensive, correct?
Yes, absolutely. So a lot of wastewater process involves big mechanical equipment, big pumps, blowers for secondary treatment, and they're all critical for the process. So water utilities use a large portion of the municipal government's energy consumption. So any way we can do to reduce that energy usage is helpful. So the microgrid, we can bring in renewable energy sources such as solar to bring down the overall energy demand of that water plant and the wastewater plant, and that saves them on their own electric utility bills.
At CDM Smith, we understand a thing or two about staying ahead of the curve. The world is facing environmental and infrastructure challenges with lasting implications, so we're building solutions with lasting results. We'll help you embrace what happens next because it's happening now. Learn more at cdmsmith.com/nextisnow. Okay, let's get back to it. We've talked about different renewable energy options, but I wanted to sort of unpack that a little bit. What renewable or alternative energy sources do you see being really useful to a water utility that wants to install a microgrid?
Definitely solar because of that peak shaving aspect. Most of the time, the highest energy consumption for a water or wastewater plant is going to be during the day when the sun is shining. If you can kind of tie the power generation and power consumption together, that will help cut down on that peak demand, especially coupled with a battery energy storage system. So solar obviously is the highest during the sun shining. So if we can store that energy and use it later, that kind of helps balance out the overall solar energy production and consumption. Another renewable energy source that's close to my heart is biogas. A lot of the work that we've done at CDM Smith in bioenergy revolves around using biogas generated from anaerobic digestion process for solid stabilization. That biogas has a great energy potential to either be used in an engine for combined heat and power. So instead of burning it in a flare, we can generate electricity, we can generate heat and reuse that all on site. Or we could even turn it into renewable natural gas and put it in the pipeline for kind of the wider public use.
So obviously, really exciting, really innovative stuff. What are some of the challenges? What are some of the primary hurdles that come to mind when a utility looks to upgrade to a microgrid?
I think there's challenges with any project in terms of kind of right sizing the equipment, but a microgrid especially has added challenges because there's so many parties at play. The biggest one is the electric utility. Working with the electric utility from day one, making sure that what the overall project is acceptable to them. Like, you're going to be reducing your electric utilities bill, making sure that they're allowing a reduction in energy. The other kind of major challenge I see with microgrids is just developing the overall conceptual plan and the design criteria. There's a lot of options out there. We've talked about solar, we've talked about biogas, we've talked about engines. There's all sorts of energy resources available. And how do you right size those? How do we say we want 2 megawatts versus 6 megawatts of solar? We need to do a lot of analysis, and the more data we have, the better. Also keeping in mind how much land is available, Solar facilities take up a lot of space. So where is there physically space to put that? And how much sun is shining in that physical space? And then the other aspect would also be just planning for the future. We've got to right size this equipment for operation now, but also plants are constantly evolving. We're constantly increasing capacity, developing new technologies, implementing additional processes. So right sizing the generating assets for now and for the future, or planning for future expansion, is always something to keep in mind when designing a microgrid.
Well, Laurel, this has been fascinating. It's always super cool to talk to you about this stuff. Thank you so much for being here with me today.
Thanks, Andrew.